Assalamualaikum and good morning everyone. We are from CSC110 Group 2G and today we would like to present our project entitled Parcel Collector Management System. This project was developed to support the digital transition of parcel management in campus environment, especially in universities. Next, this slide shows our organization structure and the responsibility of each team member. Norfatini serves as the project manager, responsible for coordinating the project and managing the overall workflow. Rose Maisara acts as the system designer, handling the UML diagrams and system design. Nurul Natika works as the report specialist, preparing the project documentation and final report. Finally, Fatin Farhana serves as the Java programmer, responsible for implementing the system in Java. Through this division of responsibility, our team was able to work efficiently and complete the project successfully. First, let's take a look at the current situation. On the left side of the slide, we can see the challenge faced by many parcel collection centers that still rely on paperwork and handwriting records. This will create messy documentation and make it difficult to track parcel information accurately. On the right side is our proposed solution. We introduce a simple database system that allows staff to track, check, store, and update parcel information quickly and efficiently. The main goal of this system is to save time, simplify daily tasks, and ensure the parcel management process runs smoothly from start to finish. Next, this slide shows the comparison between the current manual method and our proposed digital approach. In the manual system, parcel information is usually recorded in notebooks or paper forms. This increases the possibilities of human errors as misspelled names and make it difficult in locating parcel information when needed. Our proposed digital system addresses this issue by using standardized digital records and instant status updates within the system. For example, parcel status can be updated immediately from register to ready to collect, allowing staff to monitor parcel process more efficiently. This results in better accuracy, faster access to information, and more convenient experience for both staff and students.
Now, I will explain the scope of our parcel collector management system. The main scope of this project is to replace the traditional paper logbook with a digital system for managing parcel records. Currently, staff record parcel details manually, which is time-consuming and increases the risk of losing records or making mistakes. Our system allows staff to store parcel information digitally, making the records easier to manage, search, and update. Besides recording parcel details, the system also generates a receipt whenever a parcel is successfully collected. This receipt acts as proof that the parcel has been claimed. Another important scope is reducing human error. Instead of writing tracking numbers and recipient information by hand, the system stores everything electronically, making the parcel verification process faster and more accurate. Overall, this system improves efficiency, keeps parcel record organized, and provides better accountability for both staff and students. Next, I will explain the UML diagrams of our system. We use two UML diagrams, which are the class diagram and the use case diagram. The class diagram shows the structure of our system, while the use case diagrams show how users interact with the systems. First is the class diagram. Our system consists of 5 main classes, which is user, student, admin, parcel, and parcel center. The user class is the parent class because both student and admin share common information, such as username and password. The student class represents students who collect parcels. Students can enter their tracking number, verify their OTP, collect parcels, and receive a receipt after collection. The admin class manages the system. Admin can register new parcels, update parcel status, delete parcel records, view parcel information, and send notification to students. The parcel class stores parcel information such as the tracking number, receipt details, delivery date, and parcel status. Finally, the Parcel Center class manages the collection of parcels and coordinates the operation between students, admin, and parcel records. Overall, the class diagram shows how these classes work together to support the parcel collection process. Next is the use case diagram. This diagram shows the interaction between the users and the system. There are two main actors. The first actor is the admin. The admin can log in, register a new parcel, view all parcel records, update parcel status, delete parcel information, and send notifications to student. The second actor is the student. Student can log into the system, enter their tracking number, verify their OTP, collect their parcels, and receive a collection receipt. This use case diagram clearly defines the responsibilities of each user and shows how they interact with the parcel collector management system. So here we can see that the scope defines what our system is designed to accomplish, while the UML diagrams explain both the structure of the system and the interaction between users and the system. That's all for me.
In our project, we wanted to move away from hard coding data into a main class. So instead of that, we use a text file as our database to organize an input that we want the program to run, and ultimately it will populate the parcel center class. Now, by this, it's making the system much more easier without needing to touch the code and recompile the source code. So, to explain the class definition, we have a superclass we name it as user class, which have a private attribute like name, ID, email, number phone, and string name, ID in our constructor. And then we have getters, public getters, and this what we call it as encapsulation. Now, we also have toString, but we change its name by get profile details, and we will use it for later. And also a boolean login, where we will actually apply it in admin and student also for you to use and override. Now next, students are extended by user, and we have its constructor over here. We have super name and ID and email and number phone, which is you use it from user class. So, and that's what we call it as inheritance. And we just add this campus address, magic number, and current OTP. And it also have a login in the student. And this is where we use it override, because we use the same method, login as the user. It's just we change the insides. Yeah, the inside. For like this one, it will return a current OTP. This one return a get ID, and we also have it in admin. So admin extends user. It has also super name, ID, email, and number phone from user class, but we just add a role and password. Now, just now when we're talking about the login method, where we use the same, have its notation for override, and also over here, these are actually, we call it as polymorphism, where you have use on a certain class, and we have to reuse it back, the method from other class. So that's what we need to use override with the login method. So Parcel Center has a parcel. As parcel class, they can act independently. So when there is no Parcel Center, parcel class can still have its information without dependently to Parcel Center. Now, Parcel Center only acts as a organize the data of parcel, and yes, that's why we have an array over here. That in our Parcel Center class, we name it as parcel database, we use a array list. Array list is our array. So it's very efficient for us to store and organize the parcels data in the parcel center. Why do we use list, array list? Which is actually it's easy for us to add parcel and remove parcel whenever we need to. Remove the data out from the main class to an external text file like this text file here, to have a clean separation between a application logic and raw data. Yes, so these are actually very efficient because the information are not hard coded, because we can modify or update our data in our text file whenever we want to easily without actually touch our code to rewrite or recompile our code. Yeah, we don't have to. Here is how the polymorphism happens in our parcel collector management. Is in our main class we treated admin and students object as a base for our user type. Now, okay, so in our main class, we call a login method where we call a login method in main class. Java actually use its dynamic method binding to actually how do I say, the system they will decide whether they want to use a admin's login method or student login method here, where I can show you here login method here. So now here we declare current user first before we use the login method, and this is where we identify whether if the user enter username admin, that will go to the admin. It will actually store current user data with admin, or not it will use or not they will use user student. Sorry. Okay, so we will also use instead of. Now instead of, we actually for it to identify which subclass whether it's admin or student. Now this everything here allows us to perform safely a downcast of for run admin menu and runs to the flow. So specific it gets to identify a object and then run a specific methods in that subclass.
Next, I will demonstrate how this parcel management system functions through this terminal recording. Step 1. Secure login. To ensure data security, the system first required the user to log in with a username and password. Step 2. Tracking and verification. Once logged in, the user input a specific tracking number to identify their parcel. To further protect student information, the system then generates a unique one-time OTP that must be entered to verify the user identity. Step 3. Parcel retrieval. Once successful OTP validation, the system displays the full details of the parcel, such as the recipient name, metric number, delivery address, and the current collection status. Moving on to our references. The development of this system was supported by 3 main platforms that help us bridge the gap between theory and practical application. First, W3 Schools. W3 Schools serve as our primary technical reference for foundational web development. It provided comprehensive guidance on building a systematic code structure and applying industry standard program practice. Next, Gigs for Gigs. Gigs for Gigs was utilized to deepen our understanding of complex algorithm and system architecture. This resource helped us refine our technical approach and resolve specific programming challenges during the development process. Next, Phoenix Code. Phoenix Code provided valuable templates and design patterns for the user interface. It acted as a guide to help us understand how to implement clean, responsive design and manage the structural purpose of our front-end code. That's all from us. Thank you.